Hello, today's lesson is on independent events. And before we start, we need to know how to multiply or recall how to multiply fractions. So when we're working with fractions, we multiply straight across. For instance, the numerator multiplies the numerator and the denominator multiplies the denominator. So 1 times 3 is 3 and 2 times 4 is 8. And then we can reduce. There is a way to reduce before we multiply, but let's go ahead and multiply first and talk about it. The second example, if I multiply straight across, 1 times 4 is 4, and 8 times 5 is 40. Now you might be able to see that we can reduce this, and we try to find the greatest common factor, the highest number that will divide into both of them. And so we have 4 will go into 4 will go into 4 one time, and 4 will go into 40 10 times. So that's one of the ways we could reduce. There is, however, another way that we can reduce, and it's called cross-reducing, and we would do that before we start multiplying. If we can see that either one of the numerators is a factor of either one of the denominators, then we can cross-reduce. For instance, I can see that 4 is a factor of 8. So 4 will go into itself. So 4 divided by 4, if I divide by 4, this gives me 1. And 8 divided by 4, this gives me 2. So now I'm really multiplying 1 times 1, which would be 1, and then 2 times 5, which would be 10, which we just a few minutes ago when we reduced after we multiplied, that's the same answer that we had. So if you haven't seen that before, then this is going to be a little bit confusing. So I'm just going to, at this point, go straight into multiplying and then reducing. So 2 times 3 is 6, and 9 times 5 is 45. Both of these can be divided by 3. So I can reduce this, I can divide by 3, both the numerator and the denominator, and I get 2 on top and 15 on bottom. If you wanted to use cross division, then I can see that 3 and 9, 3 is a factor of 9, so I can divide 3 by 3, and now I have 1. And I can divide 9 by 3, and now I have 3. So when I when I multiply now, 2 times 1 would be 2, and 3 times 5 would be 15, which is what we had after we reduced. All right, so that's been a while perhaps since we've done that. Let's move forward. And our topic today is independent probability. When the outcome of one event does not impact the outcome of the second event, the events are called independent. And independent means that it does not affect. One does not affect the other. So when the outcome of one event does not, so let's write that, impact or affect the outcome of the second event, the events are called independent. One does not affect the other. Independent probability can be determined by multiplying the probability of each event happening, or we could say P, and then we put A, whatever the first event, and B. It's the same thing as taking the probability of A times the probability of B. And that might look daunting right now, but once you see it in action, it's very similar to what we did here. Since probability we often state in fraction form, that's why we're going to use that. So it says, use your understanding of probability and independent events to answer the following questions. In a board game, students draw a card, replace it, and then draw a second card. Determine the probability of each event. Now, something very important was just said here. When they said replace it, that often is going to indicate to you that this is independent events. If we don't replace it, then one draw could affect the other draw. So let's look at our first situation. To earn 50 points in the game, a student must draw a heart-eyed card and then an angel-eyed card. So we're going to write the probability of drawing a heart-eyed card. So I see 1, 2 that have heart eyes. And now the total, 1, 2, 3, 4, 5, 6, 7, 8. So the probability is 2 out of 8. Next, we're going to look for angel cards. And I see 1 card that's an angel out of 8. We've already counted that there's 8 cards. Remember that we're replacing it each time. And that is exactly what produces independent events. Each time we're starting with the same amount of cards because we're replacing it. So now we're going to multiply. Again, we're multiplying straight across, and we're going to get 2. And 8 times 8 is 64. And now we can reduce this. 2 is a factor of itself, and 2 will go into 64. So reduced, this would be 1 over 32. Now, you may have noticed that we could cross-reduce. In fact, this we can simplify before we begin. We would get 1/4, and that would be times 1/8. And if we multiplied straight across, we'd go directly to 1 over 32. Let's look at the next situation. To earn 20 points, a student must draw a sleeping card and then an angry card. So as I look through this, I see 1, 2 cards that are sleeping. So the probability is 2 out of 8. So 2 sleeping faces out of 8 total cards. Now we're going to put the cards back if we drew them, and now we're looking for an angry card. And I see 1, 2 angry cards. So the probability of drawing an angry card is also 2 out of 8. So now we're going to multiply straight across. We're going to get 4. 2 times 2 is 4. 8 times 8 is 64. And 4 is a factor of itself. 4 will divide into 4, and 4 will divide into 64. And that will reduce to 1/16. Now you may have noticed that we can reduce both 2 8s. They're both the same. And that would give us 1/4 times 1/4. And if we multiplied straight across, it would take us directly to the reduced version. So situation number 3 says to earn 15 points, a student must draw an angry or laughing card and then an angel card. So when we have 2 things we're looking for, we add those possibilities together. So I see 1, 2 angry cards, and I see 1 laughing card. So the 2 angry cards plus a 1 laughing card would give us 3. So there's 3 possibilities out of 8 total. Our 3 cards that are what we're looking for. So the next thing they ask us is for an angel card, and there's 1 angel card. So we're going to write that as 1, and remember we're replacing the card each time, so there's still 8 possibilities. When we multiply straight across, we're going to get 3, and 8 times 8 is going to give us 64. Now 3 will go into 3, but it won't go into 64 evenly, so we can't reduce this. So I'd like you to pause the video for a minute and see if you can write the 2 probabilities that we need to use for number 4. So please find the probability of sleeping or hard-eyed cards and the probability of an angry card, and then replay this video or start this video again when we have that done. All right, if I'm looking for a sleeping card, we have 1, 2, and then hard eyes, we have 1, 2. So 2 plus 2 would be 4 out of a total of 8. And then angry cards, we have 1, 2. So that would be 2 out of a total of 8 cards. And so now we're going to multiply straight across, and we're going to get 8 out of 64. Well, 8 will divide into itself one time, and 8 will divide into 64 8 times. So the reduced probability is 1/8. Now again, you may have noticed this fraction can reduce to 1/2. This fraction can reduce to 1/4. And if we write them in the reduced form, we are going to take 1 times 1, which is 1, and 2 times 4, which is 8. And, and this would be our probability. So please turn to the next page. So I would like you to try this on the back. Please work on this, this, and this, these 3 problems, and we'll discuss them. Let's just read through real quickly. There are 6 marbles in a bag. 3 are green, 3 are yellow. If you draw a marble, and here's the key, and replace it, then draw another, what's the probability of choosing 2 yellow marbles? So we'll discuss these in class and have an awesome day. Thank you.